Hello, everyone. We're going to go over the wall elevation material spreadsheet now. If you haven't already, go ahead and download it by clicking on this link. Start off on the user agreement tab. Please read this. This states that this spreadsheet is a property of DIY Retaining Wall LLC. So please do not share this with anyone that has not purchased this course. In addition, this spreadsheet is not an engineering tool. It is strictly an estimating and drawing tool. So please do not assume that this has any engineering calculations incorporated in it. This is just to help you estimate your materials and produce a nice wall elevation. Now that we got that out of the way, let's jump over to the project data tab. At the top here, we have a bunch of information that's going to get repeated through the rest of the spreadsheet so that you only have to enter in once. So here we have our owner name, and enter in your name, or if you're a contractor, enter your client's name. Give your project a name. So I have here backyard retaining wall, and then list your address and city and state. That's important if you ever use any of these documents for a permit application, such as a non-engineered wall, then make sure you have your address in here. All right, I'm going to jump back to the course. And I'm going to go to the choose a block system part of the course. So the purposes of this example, I'm going to use the anchor wall system's diamond system. I'm going to jump back to the spreadsheet. So we have the anchor wall system as the block manufacturer and the diamond system. I'm going to go ahead and pull. I have a cut sheet of this block system already pulled up. So I'm going to pull this over to the side here so you can see what exactly I'm entering in. So you have a couple questions here. As you hover over each of these questions, you'll see a nice little dialog box pop up. And what that does is it describes what you're entering in for each cell. So go ahead and read that when you have a chance after this video is over. So this asks, does this system have pins? This particular system does not. So that's no. Is this system hollow? You can see over here, this block system is solid, so we're going to enter a no there. And that just helps estimate the amount of wall rock that you're going to have. Next is the number of block per pallet. So the blocks are going to be shipped on pallets if you order them and have them shipped to your house. So to determine how many blocks are going to be on a pallet, so you know how many pallets to order. This next section is the linear feet of capstones per pallet. If you happen to be buying these individually, you can just enter in the length of a single capstone for estimating purposes. So here, I just have the length of a single capstone, which is here 17¼ inches is the width of the capstone. And so that's what it is in feet, 1.4375 feet. This next section has you enter in the dimensions. Here you can see broken out. Here's your height, your width, and your depth on the block. So you enter in the dimensions of your block here. Here we have a 6-inch tall block, 17¼ inches wide, and 12 inches deep. Same thing for your capstones. Enter in those same dimensions here. How much waste to include? This is an important feature that a lot of people forget about, especially if you haven't done too many home improvement projects. Every construction project has waste. It's one of the inevitable parts of construction. So here, this gives you the opportunity to enter in how much waste you think you're going to have. I recommend a minimum of 5% and increase that to as much as 10% if you have any corners, it busts to a different structure, you have curves or any stairs, or you think you're going to be cutting a lot of blocks. And this also accounts for any material that's broken during shipment, which a lot of times the company that you're buying the material from does not cover. So keep that in mind. Go ahead and include some waste in there. All right, will your retaining wall require a geogrid? So I'm going to jump back to the course. All right, I mentioned before, we're looking at the anchor wall system's diamond system. Our particular example has no slopes and no surcharges. So I'm going to click on this link. All right, and this brings up a nice estimating chart. All right. So this shows you for each height, whether you need geogrid or not and how long that geogrid needs to be. So the purpose of this, I'm going to assume that we have clay, silt, soil. If you don't know your soil type, that's a good assumption, is to assume that you have clay or silt soil. In our particular example, is a 3.5 foot wall once you account for embedment. So make sure when you're looking at these estimating tables that you account for embedment. And you can always make a guess first and then come back and adjust it. So for this, we have in this estimating chart 3 feet and 4 feet. So we're going to jump up to 4 feet since our wall is 3.5 feet tall. So go ahead and jump up to the next height increment. So in this case, we have geogrid that is 4 feet long required for our particular wall example. So I'm going to jump back here. Well, your retaining wall require geogrid? Yes. And what is the length? 4 feet. Over here, we have the roll width and roll length. So check where you're going to buy the material from and see what roll width and roll length they supply the geogrid in. The geogrid width ranges from 4 feet all the way up to 12 feet, usually in 2 foot increments. But typically, most landscape suppliers will ship 4 feet or 6 foot wide geogrid, and then check what the roll length is. And that helps in estimating these materials. This disclaimer here just reminds you that this is not an engineering program, that this is an estimating tool. So keep that in mind, that this does not calculate the length of geogrid that is required, just uses whatever length that you enter in here. This next section is what units you want to order the backfill material in. So you have the option of cubic yards, cubic feet, and tons. Now, typically you're going to order it in cubic yards, but if you are having it shipped, sometimes you'll see it in tons so that they know how much they can put on a truck. So see whatever facility you're ordering material from, they check what they supply, what they charge for the material and what units, and enter that in for your drainage stone. Your reinforced fill, which that only applies if you have geogrid. That's the fill around the geogrid. And then your base material or your leveling pad. All right. Is a perforated pipe required? I recommend you always put a perforated pipe in, but it's absolutely necessary if your wall is greater than 4 feet, if you have any sort of slope in front of or behind the wall, if you have water in proximity to your wall, any of these reasons, or you have any irrigation behind the wall, please put a perforated pipe in. You will not regret putting a perforated pipe in to help with your drainage. You have construction adhesive size that goes underneath the capstones and underneath your top block, just to make sure that those blocks don't knock off if something hits them after they're built. So select the tube size, and you might be able to order these in, say, 11 ounces or 29 ounces. Just select the one that's closest for estimating purposes. Here, you enter in the geotextile filter fabric. Similar to a geogrid, you enter in the roll width here, as well as the roll length. And this last question, do you intend to hire a general contractor? So a general contractor, they're going to cost a little bit more than, say, just a handyman or a landscaper would, because they have additional licenses, they have more experience. They'll typically help with the permitting process. So I recommend you go ahead and input that as yes if you intend to hire a contractor, just so you get a little bit better baseline for what the expected costs are for hiring a contractor. If you were to select no, that would reduce the overall cost when we get over to our cost of materials tab. Next, we're going to jump over to the layout tab. Here you can see a nice elevation view of the wall. So this is where we're going to actually draw out the wall using the inputs that we put together on graph paper earlier. So over here, you see the wall elevation. If you hover over all the lines here, you can see the elevation along the wall. This is your top of wall. And then the top of wall just happens to line up with the finished ground line. In this case, I'll show you in a minute If we move these blocks, you can see the finished ground line behind the wall. This dark blue line is the finished ground line in front of the wall, and this dashed line is the minimum embedment line. So let's jump in the inputs. I think this elevation view will make a little bit more sense. So over here, we start with the wall name. This spreadsheet only does one wall at a time, so if you want to do multiple walls, just do a save as of the spreadsheet for each wall that you want to do. This top overrun. So if you want the blocks to extend above the finished grade behind the wall, then you can enter in how much you want those blocks to extend above finished grade. So say that I want the blocks to extend 7 inches above the finished grade line for some reason. I enter in 7 here. You can see this dark blue line is the finished grade line. This dashed line is at 7 inches above the finished grade line. And the program auto-populated blocks until it got at least 7 inches above that finished grade line. Now, the reasons why you might want to do that, maybe you have a ditch behind the wall that you want some more blocks in there for. Maybe you want just a little bit of a curb, keep tennis balls from rolling off the top of the wall as you're throwing them to your dog at the edge of the yard. Something like that might be a reason why you want an extra block or two sticking up. Now, on the flip side, you might enter a negative number here if you want the finished grade line to go even flush with your capstone. So notice here, there's no capstone shown, all that's included in our materials later on. If you want the grade line to go flush with your capstone, then you'll enter a negative number here. So say our capstone is 3 inches, we'll enter negative 3 inches. So now this bumps that dashed line 3 inches below the finished grade line, and the program's going to lay in blocks until there's blocks at least above that dashed line. All right, minimum embedment. We covered this in the course. Typically, this is going to be 6 inches. If you have a short wall that's under 2 feet, this you can get away with 4 inches, but generally you want to keep it at least 6 inches. So if I were to increase this, say 7 inches, you can see this minimum embedment line bump down, and then the wall blocks bump down as well. And change that back to 6. This reference elevation. So this is an elevation somewhere in space that says, I want a horizontal joint to be at this elevation. So right now we have it at 7 feet. That happens to correlate with this line right here. Now, if I were to make this 7.25 feet, well, it's going to shift the wall 3 inches up, or a quarter foot up and down. So now you can see here, because we have this top overrun set at negative 3 inches, it's saying the top of the blocks right at that 3 inches below grade line right here. If I were to say enter in 7.1 in here, you can see the difference now. You can see that finished grade line here, and then you see that 3 inches below the ground line here, that line. Let's jump over to laying in the stations, top wall, bottom wall, and slopes. Station, you might be asking what that means. It gives a little definition here, but basically that is the length along the wall. So say you start your wall at 0 feet, and then you end it, say it's a 50-foot long wall, you would end it at 50 feet. And then when we say station, we'd say it starts at station 0, ends at station 50. That's just a term used in the construction industry. Don't get too hung up on it. It's just the length along the wall. I'm going to go ahead and pull up the example from the course. Call elevation view. So here is course example. So we have this elevation view here. And I've already entered in the lengths. And it looks like our top of wall and bottom wall are slightly off. So we should have a top of wall at 9 all the way across. So this top of wall elevation should be 9 and 9. And then our stations going back down here, our total length of wall, 26 feet. And we don't have any changes along the top of the wall, so we just need to enter in the beginning and end station along the wall for our top of wall here. So I'm going to enter 0 and 26 because that's our length of wall. Now over here, the first 8 feet, we have this constant line here. So I'd run from station 0, station 8, get to this point, and then we have a 15-foot run. So 15 plus 8 is 23. And then we have a 3-foot run where the stairs come up. So then I enter in 26. And our wall, looking at these points again, goes from our elevations along the bottom wall, go from top of wall, elevation 9, then elevation 6, 6, and then 9, get back up to the top of the stairs. Okay, I'm going to maximize this so we can. So here's our wall elevation. I'm going to jump back over here. I'm going to change this pop over run to 0. And then I'm going to change my reference elevation to 5 to 6, match our finished ground line. You can see now our bottom wall is perfectly aligned with that minimum embedment line. So that's a good opportunity to mess around with this reference elevation. Once you have the wall drawn, see how you can optimize your area. Now let me go over slopes. So the back slope here just helps with showing what the slope is. It doesn't affect any of the calculations that Spreadsheet is doing for your quantities. But your toe slope here, this does affect the embedment. So you're going to enter in the horizontal portion of the slope. So it's listed as horizontal, vertical, so every X number of feet horizontally per 1 foot vertical in slope run. That's what you're going to enter in here. So say this particular example, there is no slope, or it's very minimal. But let's say you have a 2-to-1 slope in front of the wall. You would enter in 2 here. And you see that embedment increasing drastically as we go that toe slope. And that is because we want to ensure that we're meeting the minimum embedment 5 feet out from the wall. So that's what that toe slope does. I'm going to switch these back to 0. You can also leave them blank if you want. Next, we're going to jump over to the cost of materials tab. So you can see here, we have all the information repeated at the top, the project owner, address, and the city and state. And then here we have our wall name as calculated the wall area, the maximum height, and the length of the wall at the top here. What we are going to be entering in are the costs per unit of material for all the materials listed here, and then the supplier, where we bought it from, so we know later where to go buy it after we've estimated the cost of our wall. So just an example, here you have the Anchor wall system. It costs $549 per pallet, and there's 50 each on a pallet. If you need to update the number of blocks per pallet, remember, go back to that project data tab. This gives estimate of all the materials. Down here, we have equipment. So don't forget about running your big equipment. Not many of us own a skid steer. So if you need to rent that along with a plate compactor, here you enter in the prices for that. And then you're going to estimate the number of days it's going to take you to build this wall. So if you are optimistic and think it's only going to take you 1 day, then you would enter in 1 day here. I would plan on having the tools or the equipment for at least a couple days, just to give you a little bit of buffer if the materials and the equipment gets shipped, later in the day than you're anticipating, and you're getting a late start. You just want to buffer in a little bit of extra time there. In addition, down here, the labor, so it calculates the number of man hours that are estimated to build your wall based on the square footage. This is just a rough estimate based on average blocks placed per an hour. So don't take this as gold, but you can use this as an estimate. So if you were to enter in one day here, you can see here it's estimated that you'll need 2 people to accomplish this size project in 1 full working day. But if you were to stretch that to 2 working days, you might be able to accomplish this with just 1 person. This is a decently small wall. We're just showing half of the project from our example. So in this case, then you would need this for 4 days if you're going to do that whole project that we showed in the example. So in this labor section, you have the ability to change the dollars per hour. These range by region. It's going to be more expensive to hire out labor in California than, say, it would be in Alabama, just as an example. So you can look at the average labor rates in your area, and this is the cost to the construction company, not necessarily what the worker is getting paid. Here you have a nice summary of the cost to do this wall yourself, build it yourself. In this case, it's a little over $4,000. And then the cost to hire a contractor, a little over $7,300. Then you can see the price per square foot broken down for both those as well. Now, the cost DIY, you've come up with all these prices yourself. So that is going to be pretty straightforward. That's going to be the cost to do your project along with tools that we'll go over later. But this is going to be your cost for the project. Now, the cost to hire a contractor, I recommend that you get at least 3 quotes for any construction project. And even if you're estimating the costs, it's no different. Make sure you get at least 3 quotes. This just gives you a nice baseline. If you get a quote and they're estimating $30,000, well, yeah, get some more quotes. And if you get a few more quotes and they're still pretty pricey, maybe you get a 4th quote just to see if you can get closer to this number. This is just a ballpark number, but gives you a starting point as you get quotes to know how close those contractors are, how much cost there is just in the labor and the hiring of the contractor. If you want to print these, you can hold down the Shift key and select project data, layout, and cost of materials. And then as you print, you see this nice print preview here. The wall layout tab doesn't include all the data that we entered in on the left, but it gives you a nice summary with the wall information, the project information, embedment, slopes, and a nice wall elevation view of the wall here. And then here's your cost of material breakdown as well. So that's it.